Hi everyone and welcome back to Matter for Thought. Today I have here another great content creator, GloberMon. It's my honor to have you here.
In the previous episode, we covered the fine details of the quadratic equation. This episode will deal with the last part of the motion equations, the trajectory equation. If until now the position on the axes was a function of time, that is, we always matched the position on the axes according to the elapsed time from a certain arbitrary moment, the trajectory equation skips the time element and gives us directly the match between the axes of motion. If we take again the shell from the previous episodes, then instead of having two equations, the first x of t, meaning distance as a function of time, and the second y of t, meaning elevation as a function of time, we get only one equation, the trajectory equation, y of x, which is the elevation as a function of distance. So let's see how to get it and what it looks like. We will stick to the same canon and the same velocity vector that we had previously. So let's remember what the motion equations look like in the x-axis. X of t equals 400t, and in the y-axis, y of t equals 300t minus 4.9t squared. To get the y of x function, we have to replace the t with x in the equation of the y-axis. And to do that, we have to switch the position of the x and t with the x-axis equation. So if x of t equals 400t, or in simple words, the speed of the x-axis is 400 meters per second, we can simplify it and say that x actually advances 400 units of distance for each unit of time. In order to reverse the direction, we can basically say that for every 1 unit of distance, 400 units of time pass. So in mathematical terms, it is written like this: t of x equals 400x. Now, after we switched between x and t, we'll put the new t in the y-axis equation. Y of t equals 300t minus 4.9t squared. Therefore, y of x equals 300 times 400x minus 4.9 times 400x squared. Y of x equals 300 400x minus 4.9 times 160,000x squared. Y of x equals 0.75x minus 4.9 160,000x squared. This formula looks a little weird, so let's check if we got the right formula. We remember that the shell traveled about 24 kilometers, so we'll pick a number smaller than that. Let's say 8 kilometers. So y of 8,000 equals 3/4 times 8,000 minus 49 times 8,000 squared times 160,000. Y of 8,000 equals 6,000 minus 1,960 equals 4,040, which means that the elevation of the shell when it is 8 kilometers away from the cannon is 4,040 meters. Now let's check if this number conforms with the original equations. T of x equals 400x, therefore t of 8,000 equals 20, which makes sense. 400 meters per second times 20 seconds are 8,000 meters. Now we put the 20 seconds in the elevation equation. Y of 20 equals 300 times 20 minus 4.9 times 400 equals 6,000 minus 1,960 equals 4,040. Is this number familiar to you? This is the exact same result from the trajectory equation. In the next episode, we will begin to understand functions in depth, one step at a time, in the vast topic called calculus, which is a cornerstone of math in general and physics in particular.
Thanks, GloberMon. For those of you who aren't familiar with her, a link to her channel is in the description. And that's for today, friends. We finally finished with the vast topic called kinematics. If something isn't clear enough, you know where to find me. Before I wrap things up, I want to thank my patrons. If you find the content good and the cause worthy, link to my Patreon is in the description. If you liked, give it a thumbs up, share and leave a comment. I was, as always, rndthinker, and see you in the next video.